The standard error is the standard deviation of the distribution of sample statistics. The standard error is your average distance that the sample statistics are from the mean of the distribution. It's the average distance that the statistics are from the middle of the distribution. So if you have a distribution of sample statistics that is very wide and spread out, like so, then it would have a large standard error. And if you have a distribution that is narrow, where all your sample statistics are generally near the center, near the mean of the distribution, then you would have a standard error that's small. In this video, we're going to discuss how to actually approximate the value of the standard error. Distributions of sample statistics are normally distributed, meaning you'll see that they have this bell-shaped curve. The mean of the distribution is always right in the center. It's a symmetric curve, so half the sample statistics are on the left side of the mean, below the mean, and half the sample statistics would be higher than the mean. If you calculate the average distance that the data values are from the mean, you would find that the standard deviation is this large, meaning if this were, for example, the number 0, and you had a standard error equal to 1, the average distance that the sample statistics are from the mean is 1 unit. This distance would be 1. So 0 in the center, then this far away would be 1. Another distance of that same length would be up to 2. Another and would be up to 3. Going down the other direction, again, 0's in the center, so going down a distance of 1 standard deviation, it would be down to -1, and repeat at -2, and repeat at -3. For example, let's say now we had a different distribution and the standard error were 2 and the mean were 5. Then the distribution of sample statistics would be normally distributed, bell-shaped. The middle value would be 5 because the mean is 5. And we can draw these lines in the same location. You notice how they match up with the picture on the left. But we know that this distance to the first line is 1 standard deviation's distance. But since the standard error is 2, we add 2 units. So we start at 5, we go up 2 units to 7. And then we go another standard deviation distance upward to get to 9, and repeat, we go up to 11. Likewise, on the other side, we go down to a distance of 2, we'd be down to 3, a distance of 2, we'd be down to 1, a distance of 2, we'd be down to -1. So the standard error's length will always match up with this picture, but if you know the value of the mean and you know the value of the standard error, you can actually label the values along the horizontal axis. Let's do an example. I'm going to go through example 1.2.2 from the text. It says, there are 3 candy bars on the market that are in direct competition: Yummies, Crunchies, and Tasties. Yummies got 40% of all those candy bar purchases during the previous year. So suppose during that previous year, a sample of 104 of those candy bar purchases were examined to determine if each purchase was actually Yummies or not a Yummies purchase. So the picture below shows a distribution of sample statistics. Notice it has that bell shape to it. And it's generated by a computer. We're going to learn how to do that in the next section. The vertical lines, it looks like vertical lines, they're actually just dots that are so many dots that are so close together that you can't even tell they're dots anymore. But these are actually dots. They just look like vertical lines. So this distribution is showing a set of simulated statistics that we would see if it were true that Yummies were purchased 40% of the time in the population of all purchases. Notice they're telling us here that the population proportion, pi, the percentage of all purchases, is 40%. to. Each dot is a sample statistic from a sample of size 104, meaning they went out and sampled 104 people, and the dot represents the proportion of those 104 people who actually purchased Yummies. So that has the answer to part A, identifying the contextual meaning of each dot. Part B asks us to describe the shape of the distribution and asks, do the simulated sample statistics appear to be roughly normally distributed? Do they have a normal distribution? So the shape of this distribution is bell-shaped or approximately normal. Part C then asks to estimate the mean of the distribution. And like I said, we estimate the mean to be pi equals 0.4 because that's the center of this distribution. It is the population parameter. The population proportion is 40% of all purchases are Yummies. So again, the mean of the distribution is approximately 0.4. In context, this is the population parameter, which represents the fact that 40% of all purchases were Yummies. Lastly, it asks us to estimate the standard deviation of this distribution and what is another name for that standard deviation. So as I was saying above, another name for the standard deviation of a distribution of sample statistics is the standard error. And we can draw these lines that always go in the same place on your normal distribution. And you're just estimating it if you were doing this on a problem in your text. But it's approximately like this to match up to that graph of the normal distribution that we drew above up here. And each one of those lines represents 1 unit of standard deviation further away from the mean. The standard deviation in this case, it would go from 0.4 right here up to approximately right here. So whatever this distance is. And we see labeled along the horizontal axis approximately what these values are. So here it is all written up. We have the vertical lines drawn here with 0.4 in the center and 1 standard deviation higher, 2 standard deviations higher, 1 standard deviation lower, 2 standard deviations lower. It looks to me like if this is 0.4, then this is perhaps 0.45, and this is perhaps 0.5. So it looks like the distance between these vertical lines is 0.05. So again, you could check this. If you said the distance between the vertical lines is 0.05, if you go from 0.4 down 0.05 units, you should land at 0.35, which makes sense on this graph. Go down another 0.05 units, you'd land at about 0.3, which yes, that looks like it would make sense. So it looks like the standard error on this distribution is approximately 0.05.